When we were doing the last electric supercharger dyno testing, at one point I had made some mention that I had done some testing beforehand and I had a pretty good idea of what was going to happen. I think I know what's going to happen, but because I did some bench testing yesterday, but I don't want to give away the secrets.
I don't know yet. Sounded good.
Well, since we're doing some testing beforehand, so we're going to have a pretty good idea of what's going to happen, but this is really high power testing, I thought you all might like to have a good idea of what's going to happen, and maybe something might blow up. Who knows? So I particularly wanted to let you all in on this testing beforehand because I am going to do some max power testing on 3 very interesting ESCs. There's the Cobra 5HV ESC, which is one of the ESCs that we tested on that last dyno video. There's the Ghost RC Cobra 5 Ace, which is the unlocked version of this ESC, and this one's kind of fun, and I'll show you why. And of course, there's the trusty Hobbywing Easy Run Max4 HV ESC, which has honestly been quite reliable for us, but has been constantly shutting off when we've been pegging it over 600 amps. And now, that's what I thought it was gonna do. So if you're an RC guy and you're not familiar with this channel, the reason why we're able to do this, and you'll see no RC people able to do this, is because we're running these electric superchargers and we're kind of running them undersized on an engine on the car that's behind me that makes a little too much power, honestly, for one of these units. So we're going to run multiple units, and that's what's coming up next, which is why I want to test these ESCs. Now, I did make mention, I'm going to go right into this. I did make mention of the warning on this Ghost RC thing, because this just kind of cracked me up. Let me try to show this to you all here. So it says, warning, extremely dangerous, must read safety instructions, no warranty, not under 18. Well, I know you might not be able to tell, but I'm not under 18. So, you know, I might be okay for this one. So we're gonna max load test all of these by running the P2 electric supercharger with the big Castle 2535 motor right into choke. So that is max load, that is wide open. I know a lot of people will think, and if you're a frequent flyer on this channel, you'll know right off the bat, but running it wide open with no restriction puts massive load on the motor. We're not gonna screw around with the Snorkus and the restrictor and all that I've done in previous videos. It just goes up to really high RPM, and it does work pretty well, and we see high speeds, but we see no load. We wanna load this down so that when we run this supercharger in compound with the sledgehammer that's on the car to make some real power, we know what the limits are gonna be, at least in theory. So we're gonna start with the 22 tooth pulley on all 3 of these ESCs, and we're gonna start with the trusty Hobbywing Easy Run Max4 HV. So the setup is this. We have our massive 12S, which is really a 20S LTO battery. It sits in this polycarbonate housing, which is, 1/4 inch thick, so it's kind of more or less bulletproof. It's got that big giant shot bag hanging off because we found out even at low power testing before we started rolling that it was blowing this whole fixture over. This thing is secured and clamped down to this welding fixturing table. Hopefully it stays put. We have over here, we have a tachometer, we have a current meter, and we have a voltmeter so we can see the voltage set. I could go through and pull the data logs from each one, but this is going to be consistent, and frankly, it's going to be quicker. So no time like the present, right? 22 tooth Hobbywing pull, wide open throttle. Let's hit it. All right, this kicks the power onto the battery and the ESC. Do I want to go for 15 seconds? Juan's back there behind the camera. He doesn't have a mic on him, but I'm going to go for long enough to stabilize the speed and the current, and we'll see. Because when we switch to the bigger pulley, things are definitely going to start shutting down. So the dog has done the smart thing and vacated the room. We're going to turn this thing up to full power. We're at 50.22 volts. No current, no RPM. I don't like being this close to this thing even with this thing here. Hopefully nothing falls, nothing blows over. Scam likely. Decline. Oh lordy. I know these glasses make me look goofy, but I'm gonna feel better. Oh God. Here we go. It shut off and I got no current reading. Of course I didn't. My janky ass current meter. All right, we got no current reading. And I don't know what I don't know. That was really loud. But it actually did what the Hobbywing does. It shut off. So I've killed the power. Let's let the capacitors drain down to 27 volts. So interestingly, I'm going to take these goofy things off. So interestingly, the Hobbywing ESC with the 22 tooth pulley with this motor on the car made the most power that we saw with the P2 consistently without shutting off. Actually, I tell a lie. That's not what happened. It was actually with this ESC, with the Cobra 5HV. We never tried this setup. But I would also assume that this would, in fact, not shut off on the car because it's not going into choke. It's not running wide open throttle. So I'm going to try this. We're going to do a take two here. I'm going to try this, but I'm going to back it off first just to make sure we get some current readings. So let's power it back on. Let's see if it's giving me its happy tones. All right, let's make sure we get a current reading. This is just a low power. All right, so you saw 38. We know it's going to shut off. Let's see how much current it shuts off at. I think the most we saw out of this, and it still stayed stable, was about 330 amps. Well, let's see what we get. That, I shut that off. That went over 400 amps. Yeah, it went over 400 amps, that's all I can say. That's why it shuts off. I mean, she's a runner. That works. And I didn't quite catch what RPM it spun to, but it spun. Let's make sure that we're getting a bum reading on the tach. I think the first. Yeah, let me make some adjustments on the tach sensor. It's not picking up the. There's always a friggin' problem. That's science for you. Oh yeah, this got moved way over. That explains it. Because this is science, this is really a take 3. I don't know if I'm going to bother showing you all takes 1 and 2. But all the gauges are now working. All the meters of data joy. I've got this thing cranked up to full power. All I have to do is push this little button, which makes me really uncomfortable sitting next to it. This is going to be the Hobbywing's third attempt at full power to gather some data. So let me just put on my safety glasses. I know everybody says safety squints and all that, and it's funny, haha, but if you sit next to this thing, you'll kind of get the point. This is not a joke. So I'm just stalling because I don't want to hit the button because it's right next to me. But we're gonna do it. So goofy glasses on, but I like to see things. All right, let's hit the button. Once again, I did the test, and the tach sensor got blown off. Juan says he could see it, so I'm gonna move it again. It just shoots right past 400 amps. Yeah. This thing is just not keeping it. I mean, well, this is actually the fourth take because that tach sensor, even if I tighten it as tight as I can, it still gets blown over. So I do want to get that data. I want to get that data on camera, and I want to share it with you. The motor's getting a little warm. The Hobbywing is holding up. It's like barely just above room temp, but you know, I'm going to put on my actual safety glasses because this is like seriously no joke sitting right next to this thing. If that shop bag decides to let go, and the shop bag is actually filled with gravel, and if that gravel goes into that thing, it's going to be like a grenade going off next to me. Shrapnel's going to go everywhere. The purpose of that shop bag is we found out that even in a low power test, this whole 1/4 inch thick polycarbonate and 1/2 inch thick plywood thing was getting blown around like it was nothing. So, you know, we're going to give it a fourth shot because I really want you guys to see the data. And then we're going to move to the Cobra 5HV and then the Ghost. Here we go. I'm really not enjoying this, but it's all in the name of science, right? I actually got data that time. Okay, so we hit a peak of 20,000 RPM. You saw that the current meter has got a limit of 400 amps. It just shot right past 400 amps. I didn't catch what the voltage sagged down to, but the Hobbywing cuts off. I mean, it saves itself. So it lasts a little bit longer. On the dyno, we've seen peaks of well over 600 amps where it shut off in like a second and a half. So depending on how hard you push it, you know, it shuts off. All right, so I am connected to the Castle Cobra 5HV. I wanted to give you a quick look-see at the current limiting options here. So it is set to 500 amps. That's how we've been running it. You can set a custom setting, and I assume this is what makes it different than the Ghost one. You just can't go up from 500. 500 is all you got. Sure, you can go down to 475, 450. There's nothing in between. So if you wanted 499, you're kind of out of luck. But, you know, I don't know why you would. This is definitely granular enough, I think. But yeah, 500 amps is as high as you can go. But we were hitting something other than a 500 amp battery current limit, which is what I believe this is. So, you know, and by the way, I did set the motor timing to highest motor timing. If you click on this little thing here, it basically tells you that the motor timing advanced changes the timing advance range. Low advance gives more efficiency and less power. High advance gives more power at the expense of efficiency, motor heat. Every system will respond to changes in advance differently. So, you know, I mean, down here it tells you, you know, be careful about motor heat and all that. But since we're only running these for short periods of time, we can go kind of nuts. But what I am going to do is actually go to, you know, normal is 10 degrees and, you know, highest is 20 degrees. For those of you who are straight up car guys, how cool is it that brushless motors have timing just like the engine in your car does? But, you know, we can just go to normal, I guess. I did see a performance difference between normal and highest. So, you know what? I'm going to go for 15 because, you know, that's the kind of stuff that I do. So we're going to update over here. And it's writing to the controller. And there you go. And it's done. So there we are. So that's where we're at. And by the way, when it comes to things like power settings, we do have max power set to 100%. Start power is medium. It really doesn't matter. Reverse percentage, we're not going backwards. And punch control is 40%. That's how quickly it hits. And, you know, it's not hitting all that quick. So there you have it. Perform motor test to enable a torque limit. We don't want to limit the torque at all. So, you know, and Roger's poking me in the back here. So that's just the way of the Roger, isn't it? Roger, come here. Is that the way of the Roger? Is that what you're doing? Is that the way of the Roger? Is that the way of the dog? Doug. Roger, speak. Speak. That's not speak. That's gross. All right. I think so. We're going to connect up the Castle Cobra 5 to the P2 and you know, the little chamber over there, and we're going to calibrate it and we're going to see how it does. All right, the Cobra 5HV is set up. It's in the chamber. I was going to say let's pull it, but that's basically what we're doing. Let's pull it. Let's see what she does. Let's go straight to full power. Oh yeah, safety glasses. Let's do this thing. Now, when I said I had tested it the day before and I had an idea what's going to happen, this is what I got. It was about 270, 280 amps, and we saw, you know, not really that much impeller speed. I would have to play it back to see exactly what it was because it's still pretty freaking loud, but it's hitting some kind of limit. Even though it's set to 500 amps, we ain't seeing 500 amps. So that said, you know, the Hobbywing just went full nuts and shut down. But the Cobra 5 is hitting some kind of internal limit that's not 500 amps. So that brings us to the Cobra 5HV Ghost. We're going to set this to 600 amps because I don't really want to blow this thing up. And we're going to see how this one does. We're going to, I assume it's going to do better than 270, 280. You know, is it going to be substantially different than this guy? I don't know. I haven't even taken this thing out of the box. In fact, Juan, would you be so kind as to grab me a blade? And because I have to break the seal on the warning right here. You see, I did that. I haven't opened it because I wanted you all to see it. Thank you, sir. So, let's see. Oh, we can shut that off. So, they do actually include the little communications doohickey, which is great. Does it come with the connectors for the battery? Nope. So, in all other respects, it's very, very similar to that ESC, except the bottom half of the aluminum is silver. And this is red anodized up here, but yeah, it's a very nice looking piece. I'm going to put some 8mm bullets on this thing. We're going to set it up. Like I said, I think the limits are up to 600 amps or unlimited. We're going to start at 600 amps. We're going to see what happens there. And then if that doesn't give us the results we want, then we're going to try something else. There is a bit of a warning in here that I saw. And here it is. Warning, no warranty, must read other side. And it says, the Ghost RC Cobra 5 Ace is a powerful electronic speed control designed for high-performance applications. To maximize performance, this ESC does not include hardware or software features which limit power to help protect the ESC. This ESC is sold with no warranty, and Ghost RC and Perfect Pass are not liable for incidental or consequential damages resulting from the use of this product, including personal injury and damage to other goods or property. Improper use or setup can result in catastrophic failure of the motor, ESC, and or batteries. You must use high-quality LiPo batteries, 70C, 5000 milliamp hour, 8mm connectors, and conservative gearing while closely monitoring motor, ESC, and battery temperatures. Do not use this ESC if you do not accept this inherent risk. I accept this inherent risk. Let's set it up. So we connected the power connectors to the Ghost, and it's now connected. We need to program the thing, so I figured I'd take you along so you can see how to do that, because why not? We can, we're here, let's do it. So this is what comes up when you first connect it to your Castle Link 2. Let's look at basic. Reverse type with reverse BEC voltage 5.5 volts. That works for us. This all works because we're running off our massive LTO pack, so we're never going to hit the cutoff. Start power 10%, that's fine. Start power ramp up time 100 milliseconds, that's fine. Start power hold time, I actually don't know what that is. What is that? So that is the... All right, so the start power hold time is a feature that is adjustable from 10 to 250 milliseconds. Once the start power value is reached, the power output to the motor will be held for the set value of the start power hold time. This feature is commonly used in drag racing scenarios and can be increased as traction at the starting line increases. Max power 100%, that's what we want. Reverse percentage 50%. I actually set that down to 100 or 10% rather, because we don't actually need reverse. PWM frequency. Now this is a new one, so you know, 8 kilohertz is for speed runs, 12 kilohertz is for drag racing. Now that is how fast it operates. So we didn't have that option before. So let's go to advanced. Throttle, all this is pretty much the same. Okay, motor, RPM limit. It says 5 and custom. When the RPM will be limited to the selected value. We don't want to limit the RPM at all. So I don't know why it's set to custom by default. That's kind of weird. I don't understand what that means. So the default is actually set to custom, and it's set to 5 RPM. So this is what they default to, 5 RPM, and it goes up and yeah, and here it says RPM limit is an electrical RPM. Below the table shows what that means in your car. Yeah, I get that. This is a 4-pole motor. So that's makes no sense. I don't know why that is the default. That should not in any universe be the default. And there is no way to disable. There's no option for disable. So we're just going to set it to 210 because that's effectively disabled. We're never going to hit that because that gives us, you know, I guess they mean 105,000 RPM. They should fix that too. Motor timing. Okay, let's see. Requires censored only modes. Okay, fine. Boost mode enable. This is interesting. So boost mode enable. Okay, so there's a whole bunch more stuff in this new version. Setting this setting to a high value will cause higher motor temperatures and possible motor failure. Wonderful. This setting works only in censored mode and requires we have a censored motor. The ESC will run the motor with more timing advanced than your sensors are set for mechanically. The basic rule of thumb is that higher timing will decrease motor efficiency and decrease low-end punch while increasing peak power output at high RPMs, which is what we want. Requires censored only mode. Okay, fine. So let's do censored only mode. Let's go back to motor. Let's do boost mode enabled. Yeah, possible motor failure, explosions, fire, whatever. Been there, done that. Boost timing amount. I mean, I don't know. Pick a number one from 0 to, well, there's a custom option, but 0 to 45 degrees. Don't say 45 degrees. I honestly think that may be past the point of efficiency. Pick something modest. 28? Well, there's no 28, there's a 26. But let's be even a little bit more. Let's do 22. You okay? Okay, you're okay with 22. Okay, 22. Have chosen to set timing advanced to a high value. This will cause increased motor temperatures. It's our last ESC we're testing. What could possibly go wrong? Use caution when running high temp timing advanced values, as excessive heat can cause irreparable damage to both your motor. Yeah, fine, whatever. Okay, so boost RPM activation range. 1,000 RPM is the start RPM and end RPM is 2,000. That's really low. The basic higher timing will decrease motor and decrease low end punch, but it'll increase getting the, okay, will turn. You want to set this timing setting high enough so that your low end punch is still present. will be in effect. This increases top end speed. That's what we want to do. But so I assume this is motor RPM, not electrical RPM. So we want to kick this bad boy in at 15,000 RPM, and we want it to end at 30,000. Give her all she's got. That was not intended to be in an accent because I can't do it, so why do it? All right, boost activation range. Let's see. Can't even. All right, so then there's a turbo enable. Yeah, sure, turbo too. Turbo me. This also causes motor failure and things exploding and whatever. Turbo timing amounts. The timer starts when the activation throttle percentage is reached. Only when sheet boost is set to 0. I don't understand what I'm clicking on, really, and I'm not really taking the time to read it carefully. Turbo timing is an advanced feature that enables the motor to generate additional power by electronically adjust. By the way, the Hobbywing has none of this stuff. The feature is typically utilized at higher RPMs after a safe amount of cheat boost has been. You know what? Let's just leave this off for now. We're already doing the boosty stuff. So why not? Logging, though. We do want to log stuff. So this one has log data. It has 3 sessions already. That's weird. Should we look at it? Let's download this and look at it. There's log data here. I mean, we haven't done anything with this ESC, so this can't be us. But let's see. Let's shut the stuff that we don't. Fan always on. I like the fan always on thing. I like that. That's good. Can't perform the motor test because we're not connected to our battery right now. Current limiting. Oh, current limiting. Yeah, we forgot to do that. There is a 700 amp option. You silly goose. Setting description. Not applicable. We're just going to go with 700 amps. 700 amps one. Well, the other one was 500 amps and it barely pulled 280. So 700 amps it is. We're not playing games here. RPM limits 210,000. That seems reasonable. Motor direction, reverse. Yes. And that is the default. So this one is set for that. Let's update things. I guess we're done. That took a long time. I mean, I don't know how much of that's going to make it in the video, but okay, let's hook it up and see if it blows up. That's all we can do. All right, we're set to 700 amps. This is the one we haven't tested yet. I don't know what's going to happen. It's calibrated. It's hooked up. Let's put on the safety glasses and Juan stand by with the sand in case of massive fire and explosion. I really don't know what's going to happen. Hopefully nothing blows up. Let's give it a shot. Here we go. Okay. Daddy does not like that at all. That was way more violent than the Hobbywing. That scared the crap out of me. That ESC and that ESC are completely different ESCs, and that thing's making all kinds of sounds. I don't know what to do. That like shot straight to death speed. I don't know, Juan, what do you think? Get closer to the Sigma so it can at least hear you.
Definitely got to move the tack back.
I mean, what was your impression, though? Am I wrong?
No, the whole thing moved. I thought it was going to come for you.
That scared the hell out of me. I'm not going to lie. Oh, my God. Yeah, they're not the same. They're not these two are not the same. I don't... What do I do? Do I pull it back? So the reason The reason why we're running these at full power is because that's actually the easiest thing to do on an ESC. When you back it off on part throttle, let's do that. When you back it off on part throttle, you start incurring heavy phase current draw, but lower battery draw, and you start incurring like switching losses and all kinds of stuff. It's actually kind of harder on the ESC to not run at full throttle because there you're approaching 100% duty cycle. This thing is just making beeping noises. I am going to back it off. I mean, we're set up. Might as well do it. Let's back it up to 50%. But let me try to adjust this. Yeah, you're right, man. This thing. Oh, what? How? All right. Let me make a few adjustments, and we'll be right back. That was arguably as or more terrifying than the sledgehammer. All right, I mean, let's back it off a good bit, but still fairly aggressive. And let's see what happens. It's just going straight to death. I mean, there's like no middle ground here. I have backed that off a lot. Let's back it off further. Oh, it's probably going into that boost mode. Beast mode, boost mode. Because like it's like barely off of, you know, neutral. Let's try it again. See if it does it yet a third time. Okay. That's 171 amps. That's I can live with that. That doesn't terrify me. Let's bump it up a little bit more. Well, it just chunked the... Was it the belt? Oh, the belt. The belt is done. Yeah. Well, we had a failure. That is pieces of belt. There's a piece stuck right here. It's like actually stuck to the side. Here, let's... Ow, it's hot. It melted. The belt has melted. Well, that was interesting. Welcome to science. Oh, there's a piece of belt stuck to the... Hey, Juan, why don't you reach over and peel that piece of belt off? Like, you'll see it. Come around this way. Like, see, like, right where the to the metal plate, you see there's a piece of, yeah, that thing. Yeah, here, hand me that. It's hot. Oh, yeah, it's hot. That's completely ruined, too. That's never happened before. Fortunately, I have ordered, this isn't the only belt, by the way. That thing is just wrecking stuff. And that's, obviously, we're not going to test the 28-tooth pulley. That would be insanity. Something is really different between this and that. I mean, obviously, yes, it's unlocked. It comes with all these warnings. I really didn't, you know, I thought, okay, 500 amps, 700 amps, not that big of a difference. But, I mean, mild-mannered, complete destruction. And, by the way, the ESC is still in one piece. I'm going to go look at that data log. I want to see what it did. So here's what it did. This was the first full throttle pull, and what it did was terrible things. For example, let's take a look at the first big massive current spike. Let's see, right about here. Battery current, 840 amps. Good Lord. Over 30,000 watts. That's 30 kilowatts it shoved. Now that was a short spike, and then it kind of, you know, bounced around a little bit. By the way, voltage there sagged all the way down to 36 volts, as you would expect when you pull almost 1,000 amps from even an LTO battery pack. And then it kind of leveled out in this pull. Let's go to, say, this point right here, where we're pulling a meager 585 amps, which is still almost 24 kilowatts. And we're at 40 volts, still sagging, but the RPM is 24,223. So we're actually pulling a little less current than the Hobbywing, but we're spinning just a little bit faster than the Hobbywing. And that seems to be a trend with this thing. Now, the other important detail to remember is that this will not shut down like the Hobbywing. This will just keep going until it destroys itself. Now, for our purposes, we don't need this kind of power. We're never going to be shoving this thing into choke this way. This is too much, but hey, we know it's good for at least this amount. It's way too much. These current draws are insane. Nobody's going to do this. Here's another point where it's pulling still 600 amps, 25,000 watts or 25 kilowatts, and you know, it's still spinning almost 24,000 RPM. And again, that's motor speed, and it's a 1.22 ratio, so the impeller is 1.22 times faster. Now, if I zoom out, that was the first heavy pull. You gotta zoom way out because I kept the thing powered on the whole time, for better or for worse. Where it actually chunked the belt was here. And this is actually kind of reasonable. You can tell because, you know, the power is only 13,000 watts. Let's see, current is 300 amps. Battery voltage is 44.5 volts. RPM is just shy of 19,000 RPM. This is a reasonable amount. And here you can see where the RPM started going up. That's when the belt started failing. And then I just stopped it and everything fell off. I think the belt just couldn't handle those heavy 800 plus amp hits, and we just kind of beat it to death. And on this little cruise, which really lasted what, just over 5 seconds, it just said no mas and gave up. So there you have it. This is a monster of an ESC. It really is. So I hope you all are happy. We blew something up, but fortunately it wasn't one of these ESCs. Now I know there's other ESCs you guys have made mentions of in the comments section. There's like the Mad Max ESC, which is a 16S, but it's a 300 amp unit. And basically this one at least destroys that 300 amp limitation. There are some pros and cons, which I'm not going to really get into here for purposes of this. It's also way more expensive, that Mad Max unit is. And obviously there's newer Hobbywing units out. This one's been with us for a while. But since I don't have any of those, these are what we've tested. So let me give you my sort of impressions and thoughts on these things. The Hobbywing it's a well-built unit. It's a good ESC, and it is a 300 amp unit, but it will go beyond the 300 amps, but then it shuts down. And how long it'll run before it shuts down depends on how far over you've gone. We've gone well over 600 amps, but it shuts down pretty darn quickly after that, like a second to a second and a half over 600 amps. But if you're like 350, 400 amps, it'll run for a few seconds before it shuts down. That's just what it does. And then it always restarts and always comes back. I mean, I don't hate this thing. This is a good ESC. It's held in there for, it's taken a lot of beatings on the dyno, especially if you're a regular on our channel. You'll know and you'll like this ESC. And on the newer front, there is the Castle Creations Cobra 5HV ESC. This is supposed to be a 500 amp ESC. Got to be honest with you all. We've never seen 500 amps out of this thing. We've seen anywhere from 280, 270, 280-ish to 330-ish, somewhere in there. But it acts differently when it hits its limit. It just gets to its limit and stays there. It does not shut off because it doesn't exceed that limit, basically. This guy, it's a solid ESC. We are talking about a lot of power, and it is noticeably smaller than the Hobbywing. I mean, you know, it's pretty much in every dimension. It's smaller than the Hobbywing. But is it a 500 amp ESC? Maybe. Why are we hitting this 300 amp limit? I think it's actually a phase current limitation, but I'm just guessing. I think because we are not maxing out the motor speed, this thing is not hitting 100% duty cycle or coming even close to it. I think the phase currents are getting really high, and I think that's what it's butting its head up against. But then that does not explain the behavior of what is, my understanding, physically and electrically identical, this Ghost ESC. Be afraid. be very afraid. This thing is, it looks the same. I believe it is the same hardware-wise. However, software-wise or firmware-wise, probably both, they ain't the same. I thought the warnings on the box were kind of a joke, but as you saw, I mean, this is the first thing that completely and utterly destroyed one of these belts. And it also hit the hardest of any of the ESCs we've tried, including the MGM unit on the sledgehammer behind me. In fact, if I recall correctly, this thing set a current record of well over, well, you saw it, well over 800 amps. And that's insane. And that was because it hit so hard. It accelerated that thing basically 90% of its range in like 0.2 of a second. That's crazy. That's insane. It doesn't need to hit, you don't want that to hit that hard. That's insane. You don't need that. You don't want that. And that's one of the reasons why this belt completely disintegrated, is because we did that twice in a row and then sent it on a 300 amp cruise expecting it to survive. I'm sure the damage was done at those rates of acceleration to begin with. You know, this thing, well, you saw my reaction. This thing scared me. I mean, it legitimately, and I've been testing these things for years. This thing frightened me. It's not, they're not kidding. This is not a toy. This is a monster. And I can see how you could blow it up too. Now, this thing set at 500 amps behaves how I hoped this one would behave. What's the limitation? I don't know. I mean, if I find out some more information, I'll definitely share it with you guys. But I can tell you that right now, these are the ones we're going to ride with. And for what we're looking for, you don't need this kind of power. It doesn't, remember, we're shoving that thing straight into choke, okay? It doesn't need to go, in fact, you don't want it to go into choke. If you're going into choke, you don't have enough of those. Add another one. Those things should be cruising around 300-ish or so amps at 12S. That's plenty of power. Any more than that, you're in an inefficient part of the compressor map. You're not functioning efficiently. You don't need to slam it on. That's the same as taking a massive shot of nitrous without any progressive controllers and just opening the solenoid, just slamming the engine with it. You're just going to lose traction. That's not what you want. But this was a test. We needed to see what these things were truly capable of. And I really thought I'd be putting the 28-tooth pulley on, but as you saw, well, we didn't make it to that, and we didn't need to. This thing really, this set a new bar. This is a new standard, you know, and it's really not that much more expensive than this guy, and it's still cheaper than this guy. It's kind of a no-brainer. I mean, this is the way to go. But if you're looking at this from an RC perspective, this is a high-power ESC, and it's safe. This is also a high-power ESC, but it can and will die on you if you exceed its ratings. This will just get to its rating and stay there. This one will rip your face off. It will kill your dog. It will slaughter your cat. It will do all kinds of horrible things. It'll burn your house down. It could do that literally too if you said it wrong. The warnings are not a joke. This thing is a monster. You need to be careful with this, like for real. Which makes it perfect for us because we know where the limits are. We try to test as safely as we can, and then we pull back from those because without knowing where the limits are, how do you know what you're capable of doing? And we've been testing these things for years and years at this point, so we know what we need. And while these would get the job done to a certain extent, like with these guys, we can get to 80% of where I think we should be with the P2s. This could get us past 100%, which is ideal because we can always throttle back. If you're maxed out, you can't necessarily get more. But with this one, you can pull it back and get to where you need to be. So hopefully this video helps. This is a little bit of a behind the scenes of testing I do before we do some of the dyno tests that you see. We are going to be approaching 1,000 horsepower, so we are exceeding the limits of pump gas. It's a whole nother conversation. Probably not for this video, but as you can tell, the fun is still growing exponentially, shall we say. And thanks for watching, subscribe, and here's your moment of Roger.